So beaker A has ammonia in it, and it has ammonium ion in it, and chloride in it. So what I have done is I have taken the one salt that we do have, and I have separated it for you so that we can see who do I eliminate. So I eliminate the chloride guy, and now I analyze the question and I say, who do I have? I have ammonia and ammonium, and so Ashley, what is that? I mean, what is ammonia? And who is ammonium ion? Is conjugate acid a weak acid? I have a buffer. I have a buffer. Now, that means it's only going to fall down here on 3 or 4, but I'm not quite ready to decide is it 3 or 4 until I look a little deeper. So let's go all the way through them and see which ones are buffers so I'll know which ones fall into 3 and 4. And then we'll talk about, well, which one exactly is 3 and which one exactly is 4, okay? So all we know right now at this point is that we definitely have a buffer with letter A. Okay. So letter B, same thing, a beaker. Okay, so in beaker B, we have H3PO4, we have Na+, and we have H2PO4-. Who do I get to totally eliminate? Okay. What? Hayden, Na+. All right, so Kyle, what is H3PO4? He's a weak acid, right? He's a weak acid. He's definitely an acid. He's definitely weak. He's not one of my 6. All right. Who is H2PO4-? Okay. He's an acidic anion. He's one of those exceptions. An acidic anion. He is. What is he in relation to H3PO4? He is the conjugate base of H3PO4, but he likes to be acidic when he has that choice, yes? He's one of my 2 exceptions, so he likes to be acidic when he has that choice. So, a buffer. What kind of buffer do you think I have if it contains a weak acid in its conjugate, but the conjugate likes to be acidic? A pH below 7 buffer. Because I know something a little deeper. I know my 2 anions, H2PO4- and HSO4- are my 2 anions that are an exception, and they would rather be acidic than basic, even though they can be ether. Do we know that? Have we learned that? Have we memorized that yet? Okay. All right, so buffer. And we just decided which one goes with 4. So we know that B is 4. Yes, we do. All right. Oops. Grab that. Okay. So our next one. What do I have, Nyreek, in my next beaker? HCl and NaCl, and one's strong and one's a salt. So I'm going to write all ions here. H+, Cl-, Na+, Cl-. Nyreek, what do I have? Or what goes away, or what do you want to tell me?
Okay.
Is a neutral salt. Oh, and if he's a neutral salt, then that means he goes away. And if that goes away, doesn't mean that goes away. Okay. So what do I have? I just have H+. Who did he come from? Oh, and that's one of my 6. Strong acid. So that beaker contains really nothing but strong acid? Brian, what's that? Tell me about pH of that beaker. Very low. Because it's made of strong, or it's got in it only a strong acid, right? Okay. So maybe that one goes with this one. Let's just double check and make sure there's not another one that contains like 2 strong acids, because then that would supersede 1 strong acid, wouldn't it? Okay. Just wait and see. Let's look. All right. Next speaker, Abby, what's the next speaker got in it? It's got a strong base. So it's got NaOH. I get to eliminate the Na part. And what else does it have in it? A weak base. Okay, can I show you something? And I hope it sticks. You've got a strong base and a weak base. Who dominates? Thank you. So really at that point in time, the NH3 floating around with a strong base. Here's the elephant and here's an ant. We don't care about the ant right now, right? That elephant, he might crush us. It's not a fire ant, so he's not going to hurt us. Okay, so it's only really strong base now that we have in this beaker. Where's my pH? Above 7, really above 7, because it's a strong base. And you might say, well, a strong base and a weak base is going to make it really basic. No, the strong guy dominates and the weak one doesn't even matter. Okay? All right, next speaker, Jordan. What do I have in my last speaker, E? What did you say earlier? Let's just say what you said earlier. He said when he looked at those, he's like, they're nothing. And what he was meaning was they have no relationship to each other. Okay, so Jordan, but what are they? Individually, since they're not related, what are they? One's a weak base and one's a weak acid. And so at that point, you can't just say, oh, it's neutral. Can't say that. Because one of them might be a better dissociator, making either H plus or OH minus, than the other. But Jordan, how do I know that neither one of them is a better dissociator? Because I gave you their Ks and their Ks are the same. If their Ks are the same and you've got two weak guys, then they're going to dissociate about the same amount. So this one's going to produce about the same amount OH minus that this produces H plus, which means it's going to be a nearly neutral solution. So I don't have any other buffers, which means I know that the buffer that's got a higher pH must be this one. And I could have looked at the Kb of ammonia to see that. If the Kb of ammonia is -5, what is his Ka for the ammonium ion? About 10 to the negative what? 9, right? If I know the Kb, all I have to do is look at the exponent. If I don't need an exact value, and I can predict that if I have a -5 for the Kb, then the Ka is going to be -9. How can I predict that? Because the Kw, Ka times Kb will always be Kw, 1 times 10 to the minus 14. Are those little details that you've got to know? You will drown in acid-base chemistry unless you know those little details. Can I tell you a quick story? Yesterday in this room, I had 3 individuals stay for study session. Only 3. What did I say this room should have been yesterday? Packed! A plethora of students of mine, all 55 should have been in here. You're an excuse. You're in governor's school. You're an excuse. All right, so 53 of you should have been in here. I was tired. Out of those 3 students, even though I didn't get to teach, and yeah, that's true, so 50 students out of all mine yesterday. I didn't get to teach this yesterday, so obviously I'm not going to get to it today, but you know what I taught them yesterday in study session? Acid-base titrations. And you know, because they had done some homework and some reading and outlining and taken notes, they actually got acid-base titrations like that, and they're going to be bored tomorrow in class. But they already know that. And that's the hardest part. That's the chemistry. But they take some time to always study. Do some Okay, just saying. All right, so we're done with that question. So let's stop a moment. Wherever my thing is, I'm moving and I can't stop.